Alright, we are on problem 1b. This is again the nth derivative test. It's exercise 9.6 from the supplementary reading. So we have a function y equals negative x to the fourth. We're supposed to determine by the nth derivative test whether the critical values represent relative maxima, minima, or inflection points. So let's take the first derivative. It gives us negative 4x cubed. Set that equal to 0. We have a critical value at x equals 0. Let's evaluate it at the second derivative. Negative 12x squared. Evaluating at the second derivative gets us 0, and so the second derivative test fails us. We cannot use it here. So we're going to use the nth derivative test. We're going to keep going with our derivatives until we get to a non-zero derivative. So the third derivative is negative 24x. We still get 0 if we evaluate it at 0. So we go to the fourth derivative. And that gives us a negative value, negative 24. Looking at the conditions for the nth derivative test, if the derivative that leads to a non-zero result is an even number, which it is here because it's the fourth derivative, so it's an even number. If the value is negative, then we have a concave function, and thus we have a relative maxima for the critical value. And thus that's exactly what we have. So x equals 0 is a relative maximum for this function using the nth derivative test.